So some things that are worth noting. So the standard error of the slope is going to be, it's going to be calculated for you. You just have to know where to find it, okay? And then your degrees of freedom for a t-star, remember t's are based off of degrees of freedom, okay? Because we have two separate variables, we have a little bit more wiggle room, we have a little bit more room for some problems using t. So what we do is instead of using n minus 1, we do n minus 2. I want you to kind of think about it as two variables means you're subtracting 1 twice. Does that make sense? And it was kind of the same thing when we did those chi-squares for two-way tables, because our degrees of freedom were rows minus 1 times columns minus 1. We subtracted 1 twice. Okay, so you're subtracting 1 for each variable. Is everybody with me so far? Okay. Now, this particular example is basically talking about, do people who fidget more lose more weight? Everybody good? Or in this case, gain less weight. Okay? So, what we have here is, in this case, I gave you the raw data. If I give you the raw data, you are able to type these into the calculator, and there is a t-test and t-interval in your test menu, okay? I have no intention of asking you to type all of these in. I'm going to show you the other way, okay? But theoretically, you could type them all in and get the exact same feature answers that we're about to get, okay? All right, so what we're basically, let's go through and go through the choose, check, et cetera, et cetera, et cetera, okay? All right, so for the choose, we are doing a t-interval for beta, where beta is the slope of the true line relating NEA change. By the way, NEA stands for, in this example, it stands for non-exercise activity, fidgeting, right? Like, everybody good? And fat gain. If I give you something and I'm asking you to do this procedure, I'm going to give you a set of graphs to help you make said decision, okay? So, because what we're going to do next is check our conditions. We're going to use the different graphs that I give you to check your conditions, okay? And when we check those conditions, when you reference a graph, don't say the graph, because if you say the graph here, I don't know which graph you're talking about. Does this make sense? So be as specific as possible. So our first condition if this is how we remember this, right? Okay. What did the L stand for? Linear. Okay. So our first condition is going to be, you're either going to say, hey, looking at my scatter plot, do we see a linear pattern? Or we're looking at my residual plot, do we see any pattern at all in the residual plot? Okay, so it doesn't matter to me which of those two things you do, but you certainly can't say there's no pattern in the graph, because there is a linear pattern in one graph and then there's no pattern in the other. So I need to know which one you're referencing. Everybody good? Okay, so I'm a bigger fan of the residual plot, so no pattern on the residual plot. Bless you. Independent, the weight gain is independent. Weight gain is independent. I want to be a participant in this study because they intentionally overfed them. Nom, 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 nom.
Is one way of looking at linear like easier or more strict than the other? Like, are they more strict looking for a linear pattern than random?
No. I would say they're equally interchangeable. Okay. Normal. And what needs to be normal is the residuals. So you'll be given some sort of graph of the residuals. Now, the graph of the residuals might be a histogram. The graph of the residuals might be a box plot. If it's a big sample size, box plot would be fine. All right. What we're looking for is just like we would check for normality in a t-test or a t-interval, we're looking for no major skewness or outliers within the residuals. Okay. So in this histogram of the residuals, like that's how specific we could be, right? Does this look like no major skewness or outliers? Okay. So we'll say no major skewness in the histogram of the residuals. Okay. The E was that equal variation, equal variances, the same standard deviation across the graph. When you look at your residual plot, I don't see any big fanning in that residual plot. Okay. And then random. We were given random sample. Okay. In terms of the choose and the check, are we seeing that this is we have extra conditions, but that part's pretty much the same? Okay. So next, the calculate is a little bit different because we're not just going to just throw it in our calculator, okay? We can, but I actually think it's more work. Are you guys with me here? Because if I just throw this in my calculator, I got to type these in for L1, all the NEA changes in for L1, all the fat gains in for L2, and then go in and run it, okay? I think it might be easier and quicker to just like understand the confidence interval, okay? So what we're going to do is find the T star, as that we might need to review finding T star. You draw your T distribution. We're told this is for 16 young adults, so what would my degrees of freedom be? Except for on these, our degrees of freedom is n minus 2. So our degrees of freedom will be 14. 90% confident means our tails will be 5% each. And we're using inverse T to find T star. You guys, I got 1.761 for my T star. Are we good? Are we good? All right, great. So we need to do B plus or minus T star times the standard error of B, okay? All right, so B is the slope of my sample, So if I give you this information, are you with me that this box right here has all of my calculations in it? Okay, do you guys remember how to find the slope from this box? Well, what do we know about slope? In general, y equals mx plus b is our equation, yeah? Yeah? And so slope is the coefficient of x, right? And in this case, our slope is the coefficient of, what was our x? Our x's are these NEA changes. Yeah, we can see that on the scatter plot. So essentially, to find my sample slope, what am I looking for? I'm looking for the coefficient of the NEA change. Does anybody now, staring at this box, see which number is our coefficient of NEA change? Negative coefficient of negative point. You guys with me on this? Okay. So, my B will be negative 0.00344 plus or minus. T star is going to be 1.761. And now if only somewhere I could find the standard error of my slope. Is everybody with me? So what is my standard error? Did you guys get negative 0.005? To negative 0.002. 1.761. Remember, you have to do the tail, not the middle. So you put in the 0.05, and then your degrees of freedom should have been 14.
You got
inverse T.
Yeah. Okay, thank you.
No problem. So, are we good with calculating the interval, y'all? All right. And then lastly, we are 90% confident the interval from negative 0.005 to negative 0.002 contains the slope of the true line relating NEA change in fat gain. Okay, now I want to kind of talk about like what are the big ideas from here, okay? So, like the goal of this is trying to decide, is there a relationship, like with between these two variables. In other words, can we say with certainty that people who fidget were going to gain less weight than people who didn't? Or in other words, the more you fidget, the less weight you're going to gain. Can we say that with certainty? Well, let's look at our interval. What would it look like if there was no relationship? What would happen to our slope? 0. Is everybody with me? It would be 0. And is 0 in our interval? Okay, so the entire interval is negative, which means we can say with 90% confidence that there is a negative relationship between how much you fidget and how much weight you gain. The more you fidget, the less weight you gain. We can say that we definitely have a negative slope. Is everybody with me? Okay, now, are any of you thinking, yeah, it's negative, but these values, they're still pretty darn close to 0, right? Okay, so I want us to be really, really careful of something. Are you guys with me that my calories were measured in calories and my fat gain was measured in kilograms? What would happen if I would have measured that fat gain in grams? All my y values would be multiplied by 1,000. And if all my y values are multiplied by 1,000, this becomes -5 to -2, nowhere close to 0. Do you guys see what I'm saying here? Okay, so units influence these values quite a bit, but so we don't use these exact numbers, but the sign of those numbers to make our decision, because depending on what units we measure, what if we measured these in pounds? We would get totally different numbers, but the whole interval would still be negative. Do you guys see what I'm saying there? Okay? So do not let the closeness of these numbers to 0 make you think that the slope is close to 0. And in fact, when you look at this scatter plot, it doesn't look like the slope is 0, does it? Like this looks like a strong negative relation, a moderately strong negative relationship. Everybody good? Okay. Just knowing some things I put on the test. You guys probably don't have a ton of space here, do you? Not a lot? Decent amount at the top. Okay, if I asked you to interpret the slope, or if I asked you to interpret the y-intercept, or one more, write the equation of the line. This is all review from Unit 2. And it was impossible for me to find free response questions on your test that didn't relate back to Unit 2. So I want to review those topics real quick. Okay? Okay, the equation of our line is the two coefficients. Okay, so the expectations when you write out the equation of the line, I would expect this line to look like fat gain hat is equal to -0.0034 times the NEA change plus 3.505. You guys remember, like the hat, and then we have to define X and Y. And we have to be able to find those values. Interpreting our slope for every increase of 1 calorie in NEA change the weight gain is predicted to decrease by 0.0034 kilograms. For every one X, what's predicted to happen with Y? The y-intercept happens when x is equal to 0. Like, to be on the y-axis, your x-coordinate is 0, yes? Okay, so x-coordinate with 0 here would be a person who doesn't fidget. Okay, so a person with 0 calories NEA change is predicted to gain 3.505, was it, kilograms. And again, I'm pointing this out because I'm fairly certain, if I'm remembering my answer key to your test, which I did last week, at the show, so pretty much absent-mindedly. I'm pretty sure that I asked you to interpret one of these things. So I want to review those with you guys real quick. Okay? That seems like a great place to stop. Tomorrow